Hi guys, so in this section I will introduce you guys how to do the estimation and the model selection for the exponential smoothing model. Basically we will estimate the parameter by minimizing for the standard errors, right? To all the maximum for the likelihoods of the model. But basically we will run it for both to just go and see what will be the best model to be selected. For this we will going to have a different kinds of estimation and the model. They will be clarified based on the difference in the trend component. If thus will be have no trend component, additive or additive dam, and also in another side for the seasonal component, including if there are no seasonal component, additive seasonalities or the multiplicative seasonalities. So among with them, with the combination of 3 times for 3, we have a 9 different model like that. And the same thing apply for the multiplicative errors. Okay, so we also have the difference in the error, which will be additive or multiplicative error. And you can take a look to see the detail of the description of different model. We going to do here, we use the ETS function to return and automatically generate for the optimal model based on the some criteria like a key corrected criteria. So that will be the basic idea, and we're going to see how a function with the ETS model that can be run and how they can optimize for the different one, how they can just generate for all the parameter and initial states, and finally they provide also for forecasting error and predictive accuracies of the model. So based on that, they select for the best model. Okay, but however, as I already told you, the thing will be they just run it with the optimization, and they would automatically generate for the result, so you don't really have to specify for all the result based on. Okay, now let's do it with the practice 7.6. First of all, one more time, I wanted you for the Australia tourist. Okay, and with this, the quarterly visitor night span from 1999 to 2015. And to do that, with the auto plot, one more time, auto plot of the function. And if you do and apply for the Australia tourist, you will see like all the variation, especially for seasonality, they were not stable before 2005. But after 2005, the seasonalities look quite stable and robust and consistent. So that's the reason why the people want to do for the subset, right? The people want to do for subset the data from 2005 only. Okay, so to do that, I will just do for the window and apply for the AUS tourist start from 2005. Okay, so this is all the data from the first quarter of 2005 into the last quarter of 2015, and I say it like AUST if you still remember. Okay, now let's go and run for some model. Run some model to compare. Okay, I'm going to use for the first of all use the whole winter function for the AUST's data, and with seasonal I will just assume that will be additive. Okay, and if I already run for that, the regression for the model forecasting will be created, and I will call them cost fig 1. Alright, and let's say it over here. The same function will be repeat one more time to create for the fig 2. But now over here for seasonalities, instead of the additive, I will create it for multiplicative. Okay, and I run it one more time. I run it for the third time, but now they run it with the seasonalities for the additive, and I want to do for the dam. Okay, because it's for dam, I can just create true or not. And one more time, I run it for the 4th time, but the model now run with the multiplicated for the seasonality. Okay, so of course over here you can go and run and see the summarize of each of the model. Okay, and to check for also not just the parameter, the method, and also for all the kinds of like the accuracies of the model and the forecasting error. Okay, anyway, like anyway, like we can do it, but at the same time we can create for the model by just make it all run into one single plot. So I say for first of all introduce this one with the come in with the auto plot, right? The auto plot will have to just run for the model and see the original data. Later I add for a second layer with the Fig 1 model with the whole winter with the seasonality additive only, and this will be what? The second model, second layer with the home winter multiplicative forecasting. The third one with the additive seasonality but with the dam. And the last one with multiplicative seasonality with a dam. So that will be 4 layers. Add with the original data. They go together. And later I change for the X level and the Y level title to just create for the title of the graph, and finally I want to change for the title of the legend. That's familiar with you guys if you have to run through for all the course. So I just run very quick, and you can see over here all of them has been generated at the same time. Even when they can be kind of a little bit overlap on each other, because that's unavoidable when most of the time with the kind of like the fall, whole winter function and the model, they quite similar in the parameter, so they can in some way just generate for quite the same with the result. Okay, now with one more thing we can check the residue. Okay, so I use the function check residual function for Fig 1 to see how it's going on and I repeat it for Fig 2. Sorry, right, repeat it for Fig 3. Okay, and one more time repeat it for Fig 4. Okay, so over here let's just calculate, check for the problem of all the 3 functions. I will base on the Legend box to see it beside with the data visualization. Okay, so the first model Fig 1 they create for the Legend box, and that the problem is that this model is not white noise, right? P-value of the Legend box text, they are smaller than 0.05. That means they are not white noise. And you can see over here, right? For example, the chain variation of the residual, they are not stable. Okay, that's the point. The second one, the second model, the horn winter with multiplicative methods, right? Remember about in this case, they will be a white noise. However, it still look not so good about the residue. The third one, also another white noise. But however, when we go in and check for the model, okay, you can see like they will be, I run for one more time. You can see like the first one, the second one, the third one, and the last one, they quite the same in the result. So for the fit 3, they have some kinds of like problem, but the fit 4 and fit 2, they don't have the problem of the white noise. With me, I prefer to check for the fourth season, the seasonality, so the fourth one, the fifth, the last model. But however, all the things we already run through will be just manually assigned for the characteristic of the model. Now I'm going to use the ETS function to select the ETS model with minimal AIC criteria corrected, right? With the ETS model, which one the best one? So they will be automatically select the best model. Okay, so that's very easy. I just use ETS function, and then I apply for the Australia tourism data. Okay, so they over here create for the result. That should be have a multiplicative errors with the additive trend, and also for the multiplicative for seasonalities. They also create for the parameter of the alpha, beta, and gamma, right? For the level, for the trend and seasonalities, and the initial state of L, B, and S has also created. If you really want to go it, you can check it. Okay, I say it like fixed model. Okay, and I'm going to summarize the result to see it in detail. And they also create for me also not just the parameter, but also the all the accuracies criteria, and also for the forecasting error. Alright, now another thing that I can go will be try to just plot for the result. So I want to fit auto plot for the fit. Okay, so you can see over here, this will be plot the forecasting result. Okay, right now it's not the forecasting results, actually like the ETS model actually. Okay, now we in some way can just make it a little bit like higher by combining all the residual and the forecasting error at the same time to just create, okay, into just one data set. So I combine both the residual, that's the residual of the fit model of the model, and the forecast errors from the residual but type of the response, and I create for the auto plot, and you want to see it like how they will be different or go the same with the residual and the forecasting. Okay, and the same thing, okay, I can do it with the fit model. I create for another function. So right over here, I create for another model. That should be model with ETS but additive only. Okay, and I run it. Summarize for the model. You can see it over here. Right, and we combine for the residual and forecasting error at the same time, and this will be how it looks like. Okay guys, let's finish the chapter with the section 7.7, forecasting with the ETS model. So overall, we already run for all the model of the ETS function, and this will be the time for us to run for the forecasting to create for the forecast. However, the fun thing will be like with the forecasting model in the ETS, we can clarify for the simulation and the bootstrap to make the model will run for the different kinds of methods. So with the simulation, we can create for the interval prediction interval by the simulation rather than just use for the algebraic formula. However, in another way, we can also just not use the normal distribution error, but we use the bootstrapping to just resample error again and again by run for the simulation at the same time. So that's the fun thing for the ETS model. Now let's go back and go to see how we can do it. So remember about fit model. That's ETS model optimized by the M in the multiplicated of the errors, additive of the trend, and the multiplicated of the seasonality. And this will be all the smoothing parameter and the initial state. Now let's go and apply for the forecast function with the A periods ahead. Okay. So I forecast thing A periods ahead by the ETS model. Okay. And if you run for that, they will generate for the A next quarter the data of the 2016 quarter 1 into the 2017 quarter 4. And we can at the same time apply for that to create for an auto plot. Of course I want to see for the result, and it create for the result not only with the point estimation but also for the prediction interval with the percentage of 90%, 95% and 80%. And I can also at the same time create for the Y level. Okay, of course for the X level I can do it too, but Y level I can say international visitor 9 in Australia million. Okay, and of course I can create for the X level for year, something like that, and it can help me create for this. It's clarified about this one with the forecasting for the ETS model, and the optimal model has been listed here. Okay, now remember about my simulation. So with the previous one, one more time I to repeat it, but however now I run it normally forecasting with the ANSI right formula. Okay, for the prediction interval. So forecasting one more time I use for the fixed number 6 model before in A period ahead. You can see it over here. One more time I can run go and forecast it. So I create it now, but however now I want to deal with the simulation. Okay, PI prediction interval. So simulate I will just clarify to be equal true for the element, and you see the forecasting result will be maybe a little bit different. So over here you see the two of the result is quite the same. You can go and check it for the reason why. So with the simulation, when we clarify for simulate equal true, that means the prediction interval are produced by the simulation rather than using the algebraic formula. However, even when it is clarified like phone in this case, right, when we didn't clarify for that one, they would understand that this be phone. But however, when have no algebraic formula available for the particular model, they would still have to run it and just automatically simulation. Okay, so that's the reason why for both the result is quite the same. Now I create it, but with PI produced by the simulation and bootstrapping. Bootstrapping that means resampling error. Okay. So I clarify for simulation equal true, and also for the bootstrap equal true. Okay, and I run for that. And if you really want to go and see how it look like, how it different, you can apply them and summarize for the result. Okay, and you see it over here for the model and also for all the other kinds of stuff. Right, last of all, plus the result. The forecasting result can easily do it with the model. Apply for forecasting. I one more time do it with the APIs before. However, just create for autoplot, and they will generate for the result of the AIA, or the additive for the error trend and the seasonality in this function. They create for the point estimation and also for the prediction interval. Thank you so much for listening into this section about how we can do for the model selection and how we can apply for the model to generate for the forecasting.